Let us have a look at question 3, 4, and 5 from an Eastern Cape June 2023 exam paper. So we are going to focus on the Newton's laws questions. So question 3 states a car of mass 350 kgs, so mass is known, is accelerated up along a straight hill by a net force of 370 newtons. If the car is moving up the incline, kinetic frictional force will be acting down the incline. Kinetic friction always acts in the opposite direction to the motion of the object. The net force is parallel to the hill, which makes an angle of 35 degrees with the horizontal. The coefficient of kinetic friction is 0.21. Question 3.1. Draw a free body diagram with labels of all the forces acting on the car. This is out of 4 marks, which means we are going to include 4 forces. We have normal force that acts perpendicular to the surface the object is on. We have gravitational force, which acts straight down. We have applied force that pulls the car up the incline, or you can call it the force of the car's engine. And we have Fk, kinetic friction, that acts down the incline. So this is the free body diagram of our object. Please keep in mind that normal force is perpendicular to the surface. It does not act straight up. It is perpendicular to the surface. Next, let us have a look at question 3.2. Calculate the magnitude of the. Please take note that the word magnitude implies that they do not want a direction. So if your final answer has a negative in it, for example, if you calculate acceleration to be -2, you are then going to state, therefore, acceleration will be equal to 2 meters per second squared. So you do not include the negative in your final answer because a negative shows direction. So the word magnitude tells us that they do not want a direction. So we need to calculate the magnitude of the acceleration of the car. Please keep in mind, we have the net force and we have the mass. So we can use the formula F net equals ma to solve for acceleration. So this is question 3.2.1. So we know that F net was given as 370 newtons. We know the mass was given as 350 kgs. From here, we are going to use the formula F net is equal to ma, where F net is 370, mass is 350, and we are looking for A. We can divide both sides by 350, and we therefore have the acceleration of the car as equal to 1,06 meters per second squared. So that was it. In order to calculate the acceleration, all we did was take the F net value given, the mass value given, substitute it into the formula F net equals ma, and solve for acceleration. Then we've got question 3.2.2. We need to calculate the magnitude of the frictional force on the car. So if we want to calculate frictional force, keep in mind we were given the coefficient of kinetic friction. So we're going to use the formula Fk is equal to mu k times n. We have the value of the coefficient of kinetic friction, which is 0.21. From here, we need n. Keep in mind, n is the normal force. So how do we calculate the normal force? We know that normal force is a vertical force, so we take into consideration all the vertical forces acting on the object, and we will state all the forces going up is equal to all the forces going down, and then solve for normal force. So please keep in mind, in order for us to calculate friction, we need to first find normal force. So let us go and find normal force. So here's our free body diagram. Let's just copy this as we are going to need it. So this is question 3.2.2. If we want to calculate the normal force, let us draw a free body diagram showing all the vertical forces acting on the object. So this dot is going to represent our object. We have normal force that is perpendicular to the surface. We have Fg that acts straight down. Then we have the components of Fg. So we have Fg perpendicular and we have Fg parallel. And don't forget, the angle of inclination of the slope will be the angle between Fg perpendicular and Fg. And that angle is 35 degrees. Now, if we want to calculate normal force, remember what we mentioned earlier. All the forces going up is equal to all the forces going down. So we have normal force going up, and that is equal to the forces going down, which is Fg perpendicular. So we know that in order to calculate normal force, we will need to calculate Fg perpendicular. So to do that, we're going to break up Fg perpendicular into mg cos of 35. The reason we've chosen cos is because if you notice, Fg perpendicular is adjacent, whereas Fg parallel is opposite to the angle of 35. So between sine and cos, which ratio has adjacent in it, it is cos. So that is why we use cos to calculate Fg perpendicular. From here we can substitute. Mass is 350, G is 9.8 times cos of 35. We can put this into our calculator. That gives me a value of 2,809,69 newtons. Now that we've calculated normal force, let us calculate kinetic friction. So we know the coefficient of kinetic friction was given as 0.21, and we've just calculated normal force. So Fk is equal to the coefficient of kinetic friction times normal force. We can substitute, put this into our calculator, and we therefore have kinetic friction as equal to 590.04 newtons. So that is it. In order to calculate kinetic friction, all we needed to do was find the normal force, take the normal force and the coefficient of kinetic friction, substitute it into our Fk formula, put it into our calculator, and that is it. Then the last question under question 3 is 3.2.3. So let us have a look at that. We need to calculate the magnitude of the applied force on the car. So if you remember, we were given the net force as 370. So all we are going to do is take the net force and make it equal to the sum of all the forces acting on the object, and then solve for applied force. So we know that F net is equal to the sum of all the forces acting on the object. I'm going to specifically take into consideration the horizontal forces only. So here we can state that F net will be equal to, I'm going to take up the slope as positive. So that would mean down the slope would be negative. So it is going to be applied force minus Fk minus Fg parallel. We know that net force was given as 370. Applied force is what we are looking for. Kinetic friction was just calculated as 590,04. And we need to find Fg parallel. So before we do anything, let us first go and find Fg parallel. So what I'm going to do is just move this to the bottom so we can go and find Fg parallel. So Fg parallel is equal to mg sine of 35 degrees. The reason we are using sine is because, as you can see, Fg perpendicular is adjacent to the angle of 35 and Fg parallel is opposite to the angle of 35, and sine is the ratio that has opposite in it. So from here, let us substitute. That gives me a value of 1967,37 newtons. So that is our value of Fg parallel. From here, we'll take this value and substitute it. From here, we can put negative 590.04 minus 1967.37 into our calculator, and we end up with negative 2557.41. From here, we can take negative 2557.41 to the left, making it positive. So we will then have 370 plus 2557.41. And we therefore have applied forces equal to 2,927.41 newtons. So that is the applied force. All we needed to do was remember that we were given net force, and net force is the sum of all the forces acting on the object. So we take into consideration all the horizontal forces acting, substitute it, put it into our calculator, solve for applied force, and that is it. An alternative approach would have been to use F net equals MA, and in place of F net, we substitute applied force, kinetic frictional force, and Fg parallel. In place of MA, we substitute the mass of 350 and the acceleration that we had just calculated in question 3.2.1. So that is it. That is question 3 from this Eastern Cape June 2023 exam paper. Now, let us have a look at question 4. So question 4 states, a 10 kg block resting on a rough horizontal surface is connected to a block of 15 kgs by light inextensible string moving over a frictionless pulley. Please keep in mind that it is stated frictionless pulley. That does not mean the surface is frictionless. We were told that it is resting on a rough horizontal surface, meaning that the surface has friction. So please do not confuse the pulley and the surface. The pulley is frictionless, but the surface has friction. The surface is what the block is on, that 10 kg block. Due to the weight acting on a 15 kg block, the block of mass 10 kgs started to move to the right. So if the 10 kg block moves to the right, the 15 kg block would then move down. A force of F is applied to the 10 kg block such that the system moves at a constant speed. Please take note, constant speed tells us that acceleration is equal to 0. The angle between the applied force and the horizontal is 25 degrees. Because our applied force is inclined, it is going to have an x and y component. Now, something that is very important to take note of is when dealing with a pulley, your direction is important. Don't just take any direction as positive. Always take with the direction of motion as positive or against the direction of motion as positive. So don't just assume right and up as positive. Look at the direction of motion. The object is moving to the right and down. So I'm going to take with the direction of motion as positive. So my right will be positive and my down will be positive, meaning left and up will be negative. The frictional force acting on a 10 kg block is 8 newtons. So we are given the kinetic frictional force of the 8 kg block. Question 4.1, state Newton's second law of motion in words. So we know that Newton's second law of motion states that when a net force acts on an object, the object will accelerate in the direction of the net force. This acceleration is directly proportional to the net force and inversely proportional to the mass. Then we have question 4.2. Write the net force acting on the system. Now, keep in mind, it was stated that the objects are moving at constant speed. Constant speed means that acceleration is 0. So F net equals ma. If acceleration is 0, 0 times m is 0. So your net force will be equal to 0. So let's write this out quickly. So question 4.2, we need to find the net force. Now we know that acceleration is equal to 0 because the object is moving at constant speed. Constant speed means that there is no change in velocity, meaning there is no increase or decrease in the speed, so there is no acceleration. So from here we will substitute F net is equal to ma, and because acceleration is 0, mass times 0 is just 0. So the net force is then equal to 0. Now, let us have a look at question 4.3. Calculate the magnitude. Magnitude implies that we do not need to include a direction. So calculate the magnitude of the tension on a 15 kg block. So the 15 kg block is the one that moves vertically. We've got two forces acting on this 15 kg block. That is Fg acting down and tension acting up. So let us start by drawing a free body diagram of our 15 kg block and using that to calculate the tension. You do not need to draw a free body diagram. I just want to. I find it easier to do my calculations when I have a diagram. For our 15 kg block, we have tension acting up and we have Fg acting down. So take note that the mass is 15 kgs. So from here we will state F net is equal to MA. We're taking down as positive, so it is going to be Fg minus tension is equal to MA. We can break up gravitational force into its formula mg. We can substitute, so that is going to be 15 times 9.8. Take note that g is a constant, and then 15 times 0. Take note that acceleration is 0. We've previously discussed this. From here, we have 15 times 9.8, that is 147, minus tension is equal to 0. We can move tension to the other side to make it positive, and we therefore have tension as equal to 147 newtons. All we needed to do was use our F net equals MA formula, substitute the forces acting on the 15 kg block, and then solve for tension. Then we've got question 4.3.2. Calculate the magnitude of the force applied. So we need to calculate F, the force applied. Please keep in mind that the applied force is at an angle. So if we want to use our F net equals MA formula, we are going to need to use the horizontal component of applied force in our formula. So keep in mind the horizontal forces acting on the 10 kg block are tension to the right, Fk to the left, and Fx, which is the horizontal component of applied force, to the left. So let us draw a free body diagram and then we will do our calculations. So we've got normal force acting perpendicular to the surface. We've got Fg straight down. We have tension to the right. And then we have kinetic friction to the left. And then we have applied force at an angle. And then we have the components of applied force, which is Fx and Fy. And then the angle is 25 degrees. So we know that Fy is opposite to the angle and Fx is adjacent to the angle. So if we want to calculate Fx, we are going to use F cos of 25. So we'll just make a note that the mass is 10 kgs. The kinetic frictional force was given as 8 newtons. And acceleration is 0. And we previously calculated tension as 147 newtons. So we're going to use the formula F net is equal to ma. We have 3 horizontal forces acting on this object. Tension to the right, which is positive. Kinetic friction to the left, which is negative. And Fx to the left, which is negative. So it is going to be tension minus Fk minus Fx. And don't forget, because acceleration is 0, mass times acceleration would be 0. From here, we substitute tension as 147. We substitute Fk as 8. And then Fx can be broken up into the applied force times cos of the angle 25. We're using cos because Fx is adjacent to the angle 25, and cos is the ratio that has adjacent in it. From here, 147 minus 8 is 139. We can move 139 to the other side, making it negative F. Cos of 25 is equal to 139. We can divide both sides by negative cos of 25. 139 divided by negative cos 25 is negative 153.37. Don't forget that the question stated magnitude, so we do not include the negative sign. We ignore it, as that implies direction. So this is 153.37 newtons. That is the applied force. All we needed to do was take into consideration all of the horizontal forces acting on the 10 kg object. From there, we substituted them into our F net equals ma formula and solved for applied force. Then our last question from question 4.3.3, calculate the magnitude of the coefficient of kinetic friction acting on the 10 kg block. So we are going to use the formula F net equals the coefficient of kinetic friction times normal force. We have Fk, that is given as 8 newtons. We need to calculate the coefficient of kinetic friction. That means we need to find a normal force before we can use this formula. Once we find normal force, we will then have Fk and normal force to calculate the coefficient of kinetic friction. To calculate normal force, we are going to use all of the vertical forces acting on our 10 kg block, and we are going to state all the forces going up is equal to all the forces going down, and solve for normal force. So as mentioned earlier, we are going to state all the forces going up is equal to all the forces going down. We know that normal force is going up and Fy is going up. Fg is going down. We are going to move Fy to the other side so that we can solve for normal force. So normal force is equal to the gravitational force minus the vertical component of applied force. We can break these up into their formulas. So gravitational force is equal to mg. Fy is equal to the applied force times sine of the angle 25. We are using sine because as you can see, Fy is opposite to the angle 25, and we know that sine is the ratio that has opposite in it. From here, let us substitute. So we know that the mass is 10 kgs, G is 9.8, applied force was just calculated as 153.37, sine of 25. We can put this into our calculator, and we then have normal force as equal to 33.18 newtons. Now that we have normal force and we were previously given kinetic friction as 8 newtons, we can calculate the coefficient of kinetic friction using the formula Fk is equal to the coefficient of kinetic friction times normal force. So we will substitute Fk as 8, normal force as 33.18. We can divide both sides by 33.18, and we therefore have the coefficient of kinetic friction as equal to 0.24. So that is it. In order to calculate the coefficient of kinetic friction, we needed Fk and normal force. To calculate normal force, we took all of the vertical forces going up is equal to all of the vertical forces going down and solved for normal force. Don't forget that Fy is opposite to the angle 25, so you will use the sine ratio. If it is adjacent to the angle, you use the cos ratio, and that is it. Next, let us have a look at question 5. So this is the last Newton's laws question in this Eastern Cape June 2023 exam paper. Question 5 states, a satellite of mass 380 kgs is in a circular orbit a certain height above the surface of the Earth. The Earth exerts a gravitational force of 2.65 times 10 to the power 3 newtons on the satellite to keep it in its orbit. So please keep in mind that we have this satellite that is moving in a circular orbit, meaning it is moving around the Earth. And the gravitational force, our value of F in our universal gravitational formula, is 2.65 times 10 to the power 3 newtons. So take note that what is known is the value of F, the value of G, which is a universal gravitation constant, our value of the mass of the satellite, our value of the mass of the Earth, which is also a constant, and we know the radius of the Earth as well. So the only thing that is unknown in this situation is the distance between the surface of the Earth and the satellite. Now, question 5.1 states, state Newton's law of universal gravitation in words. Now, we know that Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses. Product meaning you multiply the masses. In this case, it would be the mass of the Earth times the mass of the satellite. So it is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. When dealing with Newton's law of universal gravitation, it is very important that you take the distance from the center of a circular or spherical object. Now, a few important things to take note of is F is measured in newtons, mass must be in kgs, and R must be in meters. Sometimes a question can request you leave your answer in kilometers. That does not mean that the SI unit of distance is kilometers. Distance, our value of R, is always measured in meters. That is the SI unit. Now, let's have a look at question 2. Question 5.2 states, calculate the height in kilometers of the satellite above the surface of the Earth. So in this question, they requested our answer be in kilometers. What we are going to do is calculate the value of R in meters and then convert our final answer to kilometers. Now, what is very important is to take note that they requested the height from the surface of the Earth to the satellite. Take note that your value of R is going to be from the center of the Earth to the satellite, meaning you have to subtract the radius of the Earth from your value of R if you want to get the height from the surface of the Earth to the satellite. So this is question 5.2. Let us attempt. So what is known is our value of F is 2.65 times 10 to the power 3 newtons. The mass of the satellite is 350 or 80, I believe. 380 kgs. So the mass of the satellite is 380 kgs. We have the mass of the Earth, that is a constant, and we also have the radius of the Earth, that is a constant. Keep in mind when it comes to constants, all you're going to do is go to the back of your exam paper and look at the table of constants. You will find your values there. So the mass of the Earth is 5.98 times 10 to the power 24 kgs. The radius of the Earth is 6.38 times 10 to the power 6 meters. And don't forget your universal gravitation constant is 6.67 times 10 to the power negative 11, and that is measured in newtons meters squared per kg squared. Now, don't forget that we are looking for R, the distance between the center of the Earth and the satellite. Once we find that value of R, we are then going to subtract the radius of the Earth because the question is only looking for the distance from the surface of the Earth to the satellite. And then lastly, we are going to convert that answer, which will be in meters, to kilometers by dividing by 1,000. So I'm going to quickly draw a rough sketch of the situation. So if we are looking for h, we are going to take our value of r and subtract the radius of the Earth. Let us just make one additional note. So please take note that this area here is the radius of the Earth. So if we want to calculate the value of h, we know that r is equal to the sum of the radius of the Earth and h. So all we're going to do is solve for h from there. So we know that R is equal to the radius of the Earth plus h. If we want to solve for h, that is going to be equal to r minus the radius of the Earth. So that is it. So step number one, we are going to find the value of r using our formula. F is equal to g times m1 times m2 all over r squared, whereby m2 is going to be the mass of the Earth. Now, value of F is known. We were given that value in the question, so all we do is substitute. G is a constant, so it is known. M1, which is the mass of the satellite, was given in the question, and the mass of the Earth is a constant, so it is known. And that is all over r squared. From here, we are going to cross multiply. So it is going to be 2.65 times 10 to the power 3 times r squared is equal to the right-hand side numerator. So let us just copy this. From here, we divide both sides by the coefficient of r squared by our force 2.65 times 10 to the power 3. Keep in mind, we need to get rid of the squared on r, so we square root both sides. From here, all we need to do is put this into our calculator, and we end up with r, the distance from the center of the Earth to the satellite, as equal to 7.56 times 10 to the power 6 meters. From here, we're going to use our previous equation of h is equal to r minus the radius of the Earth, because we know that to calculate the distance from the surface of the Earth to the satellite, we take the length or the distance from the center of the Earth to the satellite and subtract the radius of the Earth. So we do not want the radius of the Earth. We're only looking for this part here, h. However, our value of r includes the radius of the Earth. So here we're going to state h is equal to r minus the radius of the Earth. We substitute 7.56 times 10 to the power 6 minus the radius of the Earth, which is 6.38 times 10 to the power 6. We put this into our calculator and we end up with 1.18 times 10 to the power 6 meters. Please take note that this answer is in meters, not kilometers. The question, if you remember, stated that we need to leave our final answer in kilometers. So to convert to kilometers, we are going to divide by 1,000. Alternatively, you can multiply by 10 to the power negative 3. So we will therefore have our height as equal to 1.18 times 10 to the power 3 kilometers. So that is it. All we needed to do was calculate the distance from the center of the Earth to the satellite. Because we are looking for the distance from the surface to the satellite, we know that we must subtract, we must remove the radius of the Earth, and that gives us our height h. And don't forget, they stated our final answer needs to be in kilometers, so you convert from meters to kilometers at the end. So that is it. That is the last Newton's laws question. from this Eastern Cape June 2023 exam paper. We went through question 3, 4, and 5.